Welcome back. Now we have some experience with timelines, and we're using a timeline to wink out from existence, at least for our sphere. Now, we saw that a timeline requires a curve, and we created a curve in the timeline. In fact, you can create multiple curves in a single timeline. Every single curve will output a value as a pin on the timeline node, which is pretty nice. But we also saw that our curve was a float curve, and when we went to add a new track, we saw that we could add other types of tracks. I'd like to explore one of these other types of tracks in this video. I'd like to explore the vector track. And I'd like to use this type of track for when our sphere pops into existence. I'd like to call this winking in. So I'm going to start a timeline when the sphere comes into existence, when it's spawned in or at the beginning of the game. And I'd like to keep things neat by just creating a new custom event. So I'm going to make a new custom event called wink in. And it's going to be similar to wink out. We're going to have another timeline, but it's going to be different. So I'm going to make some room by bringing tick over here. And now that our nodes are so numerous that we have to zoom out to see them all, I'm going to comment my tick function nodes here. I'm going to highlight these nodes, not including tick, press C to comment, and I'm going to say update location and rotation. Now I like to use different colors, so I'm going to choose a new color. Now let's just say I want to use the same color for all of my tick nodes in my entire project. Well, I need to decide on that color. And once I've decided, I can drag the color up right here to save it. It says drag and drop colors here to save, and click OK. And then later when I go and make another comment, if I go to choose a color, I can choose that color. That's a handy feature. And I also like to show bubble when zoomed out. So I'm going to click that checkbox. And when I zoom out, I can see the label there. And I may as well comment these nodes as well. I'm going to press C to comment, and I'll say start wink out timeline. I'll give this one more of a kind of dark red color, and I'll save it as well. I'm going to make it about like this. There we go. And for the wink in, we're going to have our new timeline. So let's drag off. And before I type timeline and choose timeline, I'm just going to point out one thing. You've seen me drag off nodes and get my search bar and simply search there and find certain things, but you've also seen me right click and get the search bar. In the case of the timeline is not something that belongs to BP small sphere. It's just a utility that exists in the engine. So if I search for timeline, I'm going to see it there whether I've right clicked or dragged off of a node like this. It's there regardless. However, if I were to drag off of the value of some variable, such as sphere mesh, something with a color, and search for timeline, I'm not going to find anything. Because now we're only searching for things that are context sensitive to the sphere mesh. That's because we have a context sensitive checkbox. So if I right click without dragging off of anything, I'll get a timeline. And if I drag off of wink in, it's kind of the same thing. I'm not really searching in the context of a specific object. But when I drag off of a sphere mesh, I'm now searching for things that pertain to a sphere mesh. So timeline has nothing to do with a sphere mesh. However, set world scale 3D is a function that can be called on a sphere mesh. That's what context sensitive does for us. It's useful to keep this checked. Because if I search for timeline and I see there's nothing there, I know that because I dragged off of a sphere mesh, I'm not going to find a timeline. There's no timeline for static mesh components. If I uncheck context sensitive, now I'm going to find all kinds of things that have to do with timelines. Because we're no longer searching in the context of a sphere mesh, we're searching the entire engine. So I recommend keeping context sensitive checked and understanding that whenever you drag off of the value of, say, a variable like a static mesh component with context sensitive checked, you're searching for things specific to that object. Okay, now that that's out of the way, I'm going to get a timeline node. So we're going to add a timeline, and I'm going to call this wink in timeline. And we're going to play it as soon as wink in is executed. When do we want to do that? Well, I'd like to do it right away in begin play before everything else. So I'm going to right click and search for wink in and call wink in, which will execute my wink in custom event. So let's go ahead and hook those up. And now we know that our timeline will play on begin play for the small sphere. Now we can double click our wink in timeline and add a track, but this time we're not going to add a float track, we're going to add a vector track. Let's select that. Now this track will also be called scale, but this one's different. It's a vector. If we go back to our event graph, we'll see that our output called scale is not green, it's yellow because it's a vector, whereas our wink out timeline has a scale that's a float. Well, that's because we chose to create our track using a vector. And a vector track really is the same thing as a float track, only it has 3 floats instead of 1. Now, the easiest way to create a vector track is just to handle X, Y, and Z separately. And we can turn off Y and Z by clicking on the lock icons. And now we see that the line here is red. And if we add a key by right-clicking and selecting Add Key to X, we'll see that X is what we're adding the key to. There are 3 curves here, one for each of the components of the vector. So if I add a key to X, I can choose how X is going to behave in our timeline. Now, for this timeline, we're winking into existence, and I'd like to pop in with a nice kind of bauble, almost like a bubble or a flexible ball. So we're going to start with a scale of 0 and smoothly go up to 1, but I'd like to kind of bobble around 1 and settle in on the value of 1. So my first key will be at time 0 and value 0. But I'm going to have another key. I'm going to zoom out so that I can put my key somewhere close to 1, but I want to overshoot it a little bit. Or maybe a lot. Let's say overshoot it up to about 2. So I'm going to right-click, add a key to X, and then I'm going to go down below 1. Don't want to go to a scale of below 0. That wouldn't make sense. But I'm going to go down below 1, maybe around 0.5, and add a key there. And then I'm going to slowly zero in on 1. So my next key will be overshot over 1, but not as high as that previous key. So it's going to be somewhere around here. And then the next one will be a little under. The next one will be a little over. And as I'm doing this, I'm spacing them farther and farther apart and getting closer and closer to 1. And then finally, I'm going to settle in on the value of 1. So this last one I'm going to set to exactly 1. So we have this kind of overshoot, undershoot, bobbling behavior going on. And I can highlight all of these keys, right-click, and choose Auto to make them nice and smooth. Except I want that first one to be angled so that it's going straight up first, like so. So I have this kind of wobble situation going on. The mathematical term for this type of trend is called damped oscillation. It's oscillating or going up and down, but that oscillation is being damped. Now I can click on each of these little peaks and troughs and rotate their handles if I want to more accurately control what they look like. So I may not have them spaced out quite as much. I can also click and drag on the values in the text boxes as well. Now, this is just the X component of the vector that's returned. We can have different curves for Y and Z as well. But for now, I just want to see what it looks like if we're scaling our sphere mesh with this scale value. So I'm going to take sphere mesh I'm going to set world scale 3D. And I'm going to pass in that scale vector and hook this up to update. But we have to remember that Y and Z are 0, so if we scale our sphere to 0 in any direction, we won't see it at all. So Y and Z at least need values. So I'm going to lock X and Z and add a key to Y at time 0 and set it to a value of 1 and leave it there. It's going to be 1 all the way across the timeline. And I'll do the same for Z. I'll lock Y and unlock Z and add a key and set it at a time of 0 to a value of 1. So Y and Z will be 1 all the way across, but X is going to go up and down and zero in on a value of 1. And because we're setting our world scale 3D to this vector, we should see our sphere wink into existence in a curious way. Now, I don't want a delay in my game, but for testing, I'm going to add a delay just so I can prepare myself to pay attention and watch for that wink in to happen. So I'm going to set a 2-second delay, and I'm going to play test and wait for 2 seconds. And there we go. We saw our sphere wink in, except it starts off at a scale of 1. So I'm going to take my sphere mesh and start it off at a scale of 0. I'm going to lock the scale so that I can set X to 0, and it'll set all 3 to 0. And now I can play test. And there it is. It winked into existence and then winked out. Now we can have a wobble like this in all 3 dimensions, and the wobbles don't have to coincide to each other. They can be offset a little bit. Here's what I mean. I'm going to lock the X and lock the Z, and I'm going to take my first key in the Y and set its value to 0, and I'm going to add another key, and I'm going to overshoot it just like we did for the X, but I'm not going to go to the exact same spot as the X. I'm going to offset this curve from the X by going to about here and add a key to the Y. And I'm going to follow the same trend, but the Y is going to be offset from the X. This is going to create an interesting effect. So I'm a little bit farther off to the right for my second key, and I'm going to put another key here, and another key here, and here. And as you can see, I'm just kind of following this trend, zeroing in on the value of 1. So the last one I'm going to set to exactly 1 for the value. And now I can highlight all my keys, right-click, select auto, and they're all nice and smooth. And I'm going to take that first one and angle it upward so that we're shooting up fairly quickly. And then I can tweak the handles on the peaks. And here is what the Y looks like. Now I can take a look at my sphere in game. Wow, that's a little bit different, isn't it? Let's take a look at that again. So as you can see, our sphere has its scale following these trends, right? And in the Y direction, it took a little bit longer for that most dramatic peak to occur. So I might not like that. I might want it to happen faster. Maybe I want it to go here, just before the red peak. If I want to do that, I can just take all the subsequent keys that come after it and move them over. Now, I don't want to do it with the X keys, so I need to lock the X and the Z. So I'm only highlighting the Y keys, and I can move them all slightly to the left. So now our Y curve is happening faster than the X curve. Let's see what that looks like. That looks pretty cool. I think that the Y is a little too dramatic, so I might take that highest peak and move it down. And I'm going to lock X and Z. You have to do this every time you come back in. And I'm going to make that Y curve not quite as dramatic as the X curve. So it's going to zero in on the value of 1 much faster. And you'll see that I go back and forth, play testing, coming back to the timeline, play testing, and we do this quite frequently in game development. Now, the last thing to do is have some kind of trend for the Z curve. So I'm going to lock X and Y, set the Z to a value of 0, and it'll do something similar to what the other curves are doing. It's not going to be as dramatic though. We'll have a key here and here. I'll zoom in so you can see better. Here, here, and we'll zero in a little bit faster. So the last one will be at 1. We'll highlight these keys, convert them to auto curve keys, and angle the first one up. So our Z has a similar trend, but it's different than the others. Let's see what that looks like. There we go. Looks good. So we've made our sphere wobbly. And this is a very nice effect. And it didn't require any special types of files. We didn't need sound files. We didn't need special effects, Niagara systems. All we did was change the value of our sphere's scale. And the result is that we have this nice wobbly, more interesting behavior for our sphere. And when you add that type of behavior without having to add special effects or any other types of assets that may cost money, we say that we're adding juice to our game. We've just made our sphere a little bit juicier, and it didn't cost us anything. All we needed to do was create a nice little timeline to wink in, and now our spheres look a lot more interesting when they come into existence. All right, well, we don't need this delay anymore. I'd really just like to scale up our sphere mesh immediately, which means our sphere mesh doesn't need to start with a scale of 0. It can start with a scale of 1. So we can hit that curve arrow to set it back. Doesn't need to be locked anymore either. And we should see that timer play immediately, right away, which is what we want, as we'll be spawning these spheres in during the game. So we'll see the wink in get played right away. Okay, excellent. The last thing I'll do is put a comment around wink. I'm going to say wink into existence. And I'll change the comment color to this nice red and show bubble when zoomed. And now we have organization. Excellent. So now we know that timelines are a lot more versatile than we first thought. Not only can they have curve floats, they can also have vector, among other types that we haven't even seen yet. Excellent job, and I'll see you in the next video.